Also, just jumping back in here really quick to say, for everyone who doesn't know, Anand is one of the co-founders of Patronus, which does a lot of amazing things with AI evals and some open source stuff. I'm really excited to hear your talk. I'll leave it to you now.
Also, everyone watching, please retweet this because we are really close to 10,000 people watching. We got 8,700 people watching this, and I think that this talk could push us over the line. All right.
Awesome. All right. Well, thanks so much for the quick intro. And I just got my slides uploaded here, so really excited to jump in. Thanks so much for having me, and really excited to dive into the open source world of especially AI evaluation and optimization. And so one of the biggest things that we've heard from a lot of developers and companies over the past year is they're really nervous about seeing themselves in the headlines for the wrong reasons. And of course, this has happened in a variety of different kinds of scenarios, whether it's Air Canada or Google over the past year. Unfortunately, this is what happens if you don't have really reliable, really powerful AI evaluation. And so that's exactly what we do at Patronus. In particular, what we really focus on is automated evaluation. And what we have seen, especially with AI engineers that are developing new AI products, whether they are agentic systems or RAG systems or some other kind of architecture, is that it's really hard to be able to actually measure performance and then figure out what to actually do next to actually increase performance, especially in a more systematic way. And of course, when you actually have a greater distribution or a larger volume of users, it's really hard to understand how to actually scale what's happening. And so increasingly, especially in recent months, as we're seeing a shift towards not just agentic systems, but multi-agent systems, what we're also starting to see is that it's actually really hard to understand how to even test these kinds of systems, especially because with multi-agent systems, you have agents calling other agents. And it's really hard to predict what the agent trajectories might even look like. And so how do you, if you can't really predict what agents might actually do, how do you actually be able to test and measure whether or not they will do the right thing? And of course, that's a really challenging problem. And it's something that you can't really, for example, set up predefined evaluator functions for. And so this is exactly where automated, intelligent, scalable evaluation starts to become increasingly important. And so we're seeing that the paradigm of testing LLM systems is extremely different from testing deterministic software, traditional software, like the pre-LLM era. And so that's exactly what we focus on at Patronus. And so some examples of this include evaluation models that we've actually trained, which we call Patronus evaluators. And these actually cover a variety of different kinds of domains and use cases. One, for example, being RAG, which we'll get into in a bit. Along with judge evaluators, which cover a variety of different kinds of scenarios like brand criteria and tone of voice and style and different kinds of policies. And then there's sort of the more general dimension of safety and security, which just matters for every company that is building an AI system. And so I thought I would specifically focus on some examples of Patronus evaluators, some examples of evaluation models that we've trained that we've actually also open sourced. You're probably wondering, why do we actually open source this? Well, we saw that there were a lot of development companies that were developing RAG systems, and they wanted to understand how can they actually measure whether or not outputs are grounded in context. And in particular, we just wanted to make sure and really push forward not just the research community, but also to ultimately inspire the world to be able to be able to make sure that LLM evaluation is a lot more accessible, just in general. And so in order to increase accessibility, we thought it would be great to actually open source it, so we see what the community will actually do with this, but also at the same time be able to help companies do this in a much more efficient, cost-effective, and just more meaningful way within their own environments. And so LINX in particular is a state-of-the-art RAG evaluation model specifically to be able to test for the groundedness of outputs. What's unique about this is that it actually outperformed GPT-4o and a variety of different kinds of other possible LLM judges that could be used in similar formats. And so what we saw through this approach is that models like these that are designed in nature to be really good at evaluation actually tend to outperform more general purpose judges. And so, of course, there are other benefits as well from a cost and a latency perspective, but in particular, we saw that the performance of LINX on hallucination detection for RAG was extremely strong. In addition to that, what's neat about LINX is that it actually also does well from an explainability perspective, and it actually helps you highlight specific areas within outputs that are actually incorrect or happen to be failures. And so we can go into some examples of that as well. And so here's a chart on just what the benchmarking performance looked like. And we actually benchmarked it across a variety of different benchmarks. And we sourced a lot of these different kinds of Q&A examples. And we constructed a new benchmark called HalluBench. And so HalluBench, actually, funny enough, is also available on Huggingface. And so if you want to be able to test your RAG system against a large-scale, state-of-the-art hallucination benchmark, which is now very popular in the community as well, you can check out HalluBench. And HalluBench is a construction or a mix of different kinds of domains and use cases. And we in particular saw that LINX, especially the 7DB model, did really well across a variety of different domains, whether it's for medicine or healthcare or just general knowledge types of questions. And this is actually from the paper that we published towards the end of last summer. And since then, we've actually seen that the new versions of LINX that we've introduced are actually significantly not only smaller, especially the quantized versions, but also increasingly very similar in performance to the very large models like the 7DB model. And so in general, what we're seeing is that LINX can work really well for a variety of different kinds of domains. And it really just depends on how you're using it. And of course, it really depends on kind of the underlying evaluation data quality. And so if you ever have any questions on how to use not just LINX, but any kind of evaluation model, of course, feel free to reach out anytime. And so I mentioned HalluBench. And so one of the neat things with HalluBench is that it's very diverse in the kinds of domains that it covers. And in particular, it's actually really great at covering practical use cases. And so one of the major things that we did at Patronus since we got started is really just pushing teams and companies to think beyond academic benchmarks and to think towards real practical use cases that actually matter for what you're doing. And so this is actually how we visualize HalluBench using Nomic Atlas and using the new Atlas analyst agent that they actually announced a few weeks ago. And so would definitely recommend Nomic Atlas if you're trying to use a really powerful platform to visualize all kinds of data, but especially AI data. And so so I thought I would just conclude on LINX itself. So like I mentioned, there's the 8 billion and 70 billion parameter model. We have multiple versions of them, so I definitely recommend the most recent versions. And we benchmarked it against the large-scale 15K sample benchmark HalluBench, which covers practical use cases. And in particular, LINX is great not just for explainability, but also for catching really hard to detect hallucinations. And this is in particular because we actually trained it on semantically perturbed data, including in particular chain of thought reasoning data, which was the very first time that anyone had trained an evaluation model on chain of thought reasoning data. And so if you want to read more about exactly how we train this model and just more around how it works in general, you can check out the paper on arXiv or on Huggingface as well. So the next one that I thought I would focus on is a separate new model that we actually also open sourced. And this is a state-of-the-art small language model judge, SLM judge. And so what's unique about this is, of course, it's not just an LM judge that you can use, but it's not specific to RAG use cases. It's actually more general purpose. And in addition to that, it actually is a 3.8 billion parameter model. So it's extremely small, cheap, and really fast to run. And what's great about this is it actually outperforms GPT-4o Mini on the same evaluation tasks. And we actually benchmarked it on benchmarks that haven't been trained on, especially LiveBench, for example, and others. And so we also published a paper on this as well. And what's really great about Glider in particular is it's also the first judge model that actually gives you explainable evaluations out of the box. And so it actually gives you high quality reasoning chains and scores and different kinds of highlight spans. And it actually is based on a rubric scoring method, which our paper covers a bit more about. And so it's unique in that it's sort of an all-purpose judge that also just gives you a ton more information right out of the box. And so here are just some numbers on exactly how Glider 3.8b actually performed. And so this is kind of some of the performance that we were seeing in general. And so I thought I would also just generally talk a bit more about how we think about benchmarking and why it's really important. And so in general, what we see companies really struggle with is really understanding, of course, how well their systems actually perform, and can they actually trust kind of the metrics that they see, or the metrics that they quantify. Ultimately, we tell developers that it's extremely important to construct really, really good, high quality golden data sets that are very representative and diverse. And of course, that applies to also how you should think about the different kinds of evaluation models and guardrail models that you use. And so ultimately, you want to make sure that that not only LLMs, but even guardrail models are really good for your very specific use case. And so we've seen that models like LINX tend to be really good for practical use cases, but they may not work for everything. And evaluation itself is not a one-size-fits-all problem. And there is an iteration process that it takes to get it to work really well for you. And so ultimately, of course, if you see that LINX or any kind of evaluation model doesn't perform well against the data set that you have on your very first try, I just would say don't be discouraged. It could be a data quality problem. It could also be a problem with the evaluation model and maybe the way that you're prompting it. And so it may just take some iteration until you actually get to what you ultimately want to achieve. And so if you ever want to be able to try to understand how to use these kinds of evaluation models, whether open source or not, always happy to chat. Feel free to reach out to me or DM us directly on Twitter or LinkedIn, and we'd love to set up a chat. So that's all I had for today. But thanks so much for having me, and I'm really excited about the future of open source AI.
That was awesome. Thank you so much. And just to check, as you were testing your models, was that you were doing it in Nomic? We saw sort of a similar. Andre gave a demo earlier. Was that is that what you're using to debug some of these?
Yeah, we were using Nomic Atlas to be able to visualize any kind of evaluation data, including benchmarks like HelloBench. And that helps us generally understand not just what, for example, our customers might be doing with Patronus, but also understanding how the benchmark is constructed. Are there any potential biases in the benchmark itself? And I'd say it's been great and really not just pushing us, but really just pushing the community forward and really, really high quality evaluation data.
Awesome. Well, thanks so much for joining.
Awesome. Thanks so much for having me. This is